This is the Week 6 online lecture for testing and debugging. In this presentation, we're going to talk about how we can fix our problems that we find in our code and different ways to write better code. Again, this was to be the Week 6 lecture, but we're putting it online due to missed classes because of my absence and illness. And so without further ado, we're going to go ahead and get started. A lot of people think, especially with the small projects that we're doing in class, why is testing so important? And I mean, we know that we need to make sure our code works, but why so much formality around testing is a question I hear quite frequently. And keep in mind, there are whole departments at software firms, they're usually called quality assurance departments, who exist strictly to test the software that's made and make sure that it works the way the specifications and requirements documents say that it should work. Now remember, the specifications and requirements documents are the first things that come out of any software project. They tell us what the end user wants us to do. And while these departments are really helpful at spotting problems and make sure things work, as a programmer, you've got some responsibility to make sure the software works as specified and be as bug-free as possible. Now, we're all humans. We're all going to make mistakes. But the idea is the more eyes that we put on this and the more structure we put towards this idea of testing, the better our software and our code is going to be. So in this discussion, I want to talk to you about some tools that we have, not only processes we can use, but some tools we have in the development environment we've chosen to use, which is NetBeans, that can help us test our code. Now, every software development environment is different. What features that it offers towards testing and debugging are going to be different. Since we are using NetBeans in this class, I'm going to stick with NetBeans. That doesn't mean that these features aren't available elsewhere. I'm just going to stick to how they work in NetBeans. And we're going to see one of the reasons why I picked NetBeans as the development environment for this class. We're also going to talk a little bit about some features of NetBeans that are going to help our code make sure that it meets sort of the standards and guidelines, generally accepted standards and guidelines for Java software. So let's get started. Again, some of the topics that I want to talk about in this discussion and through the demonstrations and videos we're going to watch. The importance of testing. We're going to talk for a few minutes about some of the problems that have come up because of bugs in software. And so to sort of illustrate to you the importance of a testing strategy and a development style that helps us to make sure that our code's bug-free, because some of these bugs that I'm going to talk to you about in a few minutes are huge and cause so much problems. Then I want to talk to you a little bit about, I'm just going to speak for a few minutes, and then I have another video I want you guys to watch about test-driven development. It's a YouTube video that's out there that I really enjoy. I think it does a very good job of explaining the process, far better than I could, of explaining the idea behind test-driven development. Because I think it's something that you could probably start thinking about and start using, especially when you're building class libraries, almost immediately. We're going to talk a little bit about a testing framework called JUnit. It is a testing framework that is used in test-driven development. So we're going to talk a little bit about what it is. We're going to watch a demonstration, an exercise of building tests for JUnit and running them and seeing how they work. You don't have to use a framework like JUnit to do tests. You could write a test application to do it, but We're going to look at using the JUnit framework to write your tests. We're going to talk about something called static code analysis and what it can do for you. And then we're going to, once we've sort of tested our program and we know where our problems, we know what our problems are, we're going to talk about using breakpoints and watches to track them down and find out what code is causing those problems in our software. Let's talk a little bit about why testing is so important. Again, it doesn't seem important in these smaller applications that we're doing, but in the grand scheme of things, if you walk out of this class and decide you want to go be a software developer, you have to understand, and this is something that isn't really taught, how important testing is, and that there is sort of a rhyme or a reason to why we test and how we test. Let's look at some things. Let's look at some programming errors or software bugs and sort of the mayhem that they have wreaked in their that they have left in their path. There was a radiation therapy machine called the Therac 25. It was used for radiation therapy and cancer treatments in the early 80s, and there was a bug in the software that actually caused some patient deaths in the early 80s. Because, again, there were bugs in the software that controlled the Therac 25 radiation therapy machines that actually caused some people to die. They were overdosed on their radiation therapy. A rather expensive prototype rocket designed by the European Space Agency destroyed 60 seconds after launch due to a bug in the guidance computer, due to a software glitch. A Chinook crash from the British Royal Air Force killed 29 people because of a bug in what is believed to be a bug in the engine control software. These are just three rather large examples of problems caused by computer bugs. And if you needed any more reason, and this is why business takes this so seriously, let's talk about money. Let's talk about the money involved in this. In 2002, the National Institute of Standards and Technology concluded software bugs or errors are so prevalent and so detrimental that they cost the U.S. economy $59 billion with a B, $59 billion annually, which roughly translates into about 6% of gross domestic product. So, software bugs are big issues. Anytime Windows has crashed on you, that is a bug, either in the software that you're using in Windows or a problem within Windows itself. All of these Windows updates, software updates that you see put out, are out there fixing bugs. Some of these bugs could have been found and corrected. Most of the software that we use, we might lose a little bit of data. We might lose some time at work. Time is, of course, money. But most of the software bugs that we encounter don't cause large problems like crashing aircraft or blowing up rockets or killing patients. But we do need to be careful around bugs and testing to make sure that we don't put our software doesn't put ourselves in a position of killing people, as some software bugs do. This is sort of why I'm in the field that I am. I'm not really wanting to deal with some of that stuff. That's why I do patient charting software as opposed to integrated software for medical devices or guided missile systems. But there are tools that we can use to help mitigate the number and severity of the errors that we find. There are whole disciplines around this. And one of those disciplines is called test-driven development. Now, we're going to watch a video from a firm that specializes in teaching the Agile programming methodology. One part of Agile is this idea of test-driven development, and it's something that a lot of people use, even if they don't follow the full Agile methodology. But again, test-driven development is one of many different development methodologies. It is part of a much larger sort of development system called Agile, but it is used even by people who don't use the Agile method for project management and system design. But basically, it works this way. You sit down, somebody approaches you and says, we need to add a feature to the application. And you guys work out the specifications and the standards for the feature or the functionality. The first thing that you do is you go out and you write a test. You write some code that would determine whether or not that feature or functionality works. And of course, at first it's going to fail because there isn't, that feature or functionality doesn't exist yet. And that's okay. It is going to fail at first. The idea here is to write the test that writes the test that would represent a way of determining if the requirements work or not, whether or not the code meets the requirements. And if the code doesn't exist, obviously the test is going to fail. Then you start writing that feature or functionality, and you write just enough to get that test to pass. So the bare bones functionality needed to make the test pass. And then you go on and refine that functionality and make it work better and adhere to standards and clean it up. The idea here with test-driven development is to work on one piece at a time. So again, that whole idea of object-oriented programming, being able to chunk things up into smaller and smaller bits, shows up here in testing methodology. Focus on one little feature or function. Write a test to make sure that it works. And then write the code to pass the test. This is a great methodology so long as you understand the requirements and the test really is representative of what the feature or function should be doing. We're going to watch a YouTube video that goes into much better detail and provides some really great examples of this, sort of general examples of the process. The guy that is doing the narration of the test is British, so you might have to listen to it a couple of times. His accent's kind of thick and he moves kind of fast. It's only a 2-minute video. But if you click on the next item in the list for this presentation, you'll see the YouTube video. Go ahead and watch that. And then when you move on to the next slide, we'll pick up the discussion where we left off.